The initial stage of a Maillard reaction involves amino acids and reducing sugars reacting to form a Schiff base. In the intermediate stage, the Schiff base undergoes a Maillard rearrangement to produce intermediate compounds. And in its final stage, the compounds break into different compounds such as pyrazines, fluorines, melanoidins, which contribute to the flavor and brown color. And I got this from sciencenotes.org. The Maillard reaction mechanisms begin with the formation of an N-substituted glycosamine along with water from the reaction between the amino group of the amino acid and the carbonyl group of the reducing sugar. Now, the glycosamine is transformed into kerosamines via a Maillard rearrangement. These kerosamines undergo further reaction via several pathways and can form reductones, butanedione, and methylglycol, and several other products of short-chain hydrolytic fusion. These kerosamines can also go on to form melanoidins and other brown nitrogenous polymers. This imports the characteristic brown color to the food. I got this from the website BYGUs.
This is the before, where you can see the steak is clearly red, and this is the after, where you can see the steak is clearly brown. And as you can tell by the change in these colors and the taste in this steak, the Maillard reaction occurred.
Not only does Maillard reaction explain the browning of steak, it also explains the browning of toast, bread crust, french fries, pancakes, roasted almonds, toasted marshmallows, roast chickens, bagels, caramelized milk, pretzels, grilled vegetables, tortillas, dried fruit. The list goes on, and this is based off of the Maillard reaction by sciencenotes.org. Now, moving on to social topics. Speaking of the browning of toast, acrylamide is a cancer-causing agent and is a byproduct of the common Maillard reaction, where reducing sugars, such as fructose and glucose, react with the amino acid asparagine. And a good example of this is when toast becomes more than just toast. It becomes a really, really black toast. And as you can see in this image here, as shown, this one at the bottom right has high acrylamide levels, whereas the top left has low levels. Which means the bottom right has more cancer-causing agents, whereas the top left contains less.
And this is based off the National Library of Medicine on the scientific article Dietary Acrylamide and Human Cancer, a systematic review of literature, published on 2014, May 29th.